everyone. Welcome to Module 7 of AI Foundations, Session 2, MLOps Deep Dive. Our speaker today is Dan. So if you have any comments or questions, please use the chat or the Q&A box. With that said, I will hand it over to our speaker. Enjoy the session.
Thank you so much. Yeah, again, this is Dan Darnell. Super happy to be here with you all to talk about MLOps in more detail today. And if you missed the prior session, please go back and look at the overview session. That'll give you some introduction to these key topics. Today, we're going to dig into some additional details. And this session is not meant to be overly technical, but it should give you a good in-depth look at key capabilities and features of MLOps that you should be looking for in your business as you build out these capabilities or as you talk with vendors about these capabilities and things like that. So MLOps is a new discipline. And so lots of different definitions exist out there. A lot of people talking about a lot of different capabilities. It goes by a lot of different names, including model ops or ML space ops. And it's not just technology, it's also knowledge of the best practices that you need to deploy. And that's a lot of what we're going to talk about today is what does the technology look like and what are those best practices that you need to look for. So MLOps is really broken down into 4 key areas. There's production model deployment, which is getting that model kind of up and running initially. There's production model monitoring. So what are those tools that you can use to understand if your model is working as expected in production? There's lifecycle management, which is how do I manage the ongoing lifecycle of my model running on my production environment or environments, right? And finally, there's production model governance, which is, hey, we need to make sure that we are compliant and that we are tracking all the things we need to track and that someone is not manipulating our models, especially as they're related to mission critical applications for our business. And this is what we're going to go through today is all 4 of these modules in a bit more detail. So this is machine learning operations, the deep dive, actually session 2, part 1 on production model deployment. So in the last session, we talked a little bit about how MLOps can help you deploy models to containers in Kubernetes, but I think it's important at this level to understand that models can be deployed in a variety of situations. And how you deploy the model and where you deploy the model is going to be very dependent on the use case under which you plan to use it. And so deploying a model to Kubernetes and putting a REST endpoint in front of that is certainly a viable way to deploy models. And that REST endpoint can be used for interactive real-time requests. You could use that for batch processing as well, but you'll find that deploying a model, directly to a database, for example, might be a better way to do batch processing. So there's a variety of ways you can deploy models. And as you think about model deployment, you should think about, well, how do we intend to use this? What kind of response time do we need? What kind of throughput are we going to be asking for? And, where are those requests coming from? And that'll tell you a lot about kind of where your model should be located, what kind of technologies you should think about using to deploy the model into production. Now, that being said, I want to talk a little bit about some of H2O's technology in the deployment space, which this is not something that's brand new or even part of this whole thing that we have called MLOps. But one of the things you really need for deployment is a deployment ready model artifact. And we talked about that in the prior session, but now I want to introduce this idea of the H2O Mojo, which is a flexible way to deploy models into production. So any of the H2O products, whether that's H2O Driverless AI, which is an auto ML product, or the open source products, produce what's called a Mojo. And that Mojo is a it's a model optimized, it's a Java object that you can deploy. And that comes along with a series of runtimes. And we talked about this before, that you need not only the model itself, but you also need kind of you need the interface for it, and you need all the dependencies around that. And that's what the Mojo really gives you. And that allows you to take that framework, that Mojo framework, and literally deploy that anywhere in your infrastructure. So maybe not just to Kubernetes, but also to these other places where you might want to run in your infrastructure. Just to look at that in a little more detail. So you see here you have the Mojo pipeline. You have all the kind of infrastructure you're going to need to run it. Then the question is, where do you want to run it? And that could be anywhere from a REST server to AWS Lambda function, relational database, Spark, could be a Kafka queue. Lots of different places you might want to deploy a model. So again, just raising awareness that there are more places than just Kubernetes to deploy models. In terms of MLOps, what you'll typically hear is containerizing models, deploying them out to Kubernetes. But you certainly should open your eyes and open your mind to the variety of other options and places you might deploy models. So in this example, we train the model, the winning model is generated, we create that scoring pipeline. Now we need to deploy that scoring pipeline out and manage it. And that's when we talk about MLOps. And then some application is going to use that model that we've deployed. And that could be anything from a smartphone. It could be a predictive maintenance application that's running on a fleet of vehicles. It could be anything, right? So as we think about MLOps and we think about models, 2 key points. Remember, you need a production-ready model artifact. You're going to need the production runtime for that artifact to make sure that it can operate properly and take requests and respond. And you need the right form factor. So you need to make sure that if you're going to be doing super high volume batch requests, that you set up your system properly for that. And similarly, if you're going to be deploying out onto the edge, that you have an artifact and a framework and a setup that will work for that. So we talked about this last time, but just in terms of container management, what are the different layers that you're looking for? Well, you're going to have that code for the model. You're going to need to have all the dependencies for that model so that it can run, so you can make a request to it, and all of the libraries that it needs to process that request are available. You're going to need the additional infrastructure in place. Depending on what technology you use, in this case, we're talking about container management with Kubernetes, you're going to need the additional infrastructure in place in order to run that code successfully in whatever framework you're in. In this case, we're going to need a container, and we're going to need a container management system. And that's kind of what we end up with when we use Kubernetes, is a bunch of these containers, which, by the way, have the model and all its dependencies and everything in each of these, and is running those each independently, and it can take requests. Now, I will point out that when you get into this situation, you have multiple containers running, you do have to set up your monitoring, which is our next topic, to monitor all the information across those containers, right? To collect that information and to display that. So there's definitely a role for MLOps. Even if you're just deploying to Kubernetes, there's a big role for understanding what's going on within that container environment. And if you're deploying out to any other infrastructure, there's a big role for MLOps in terms of keeping track of all those deployments, monitoring those deployments wherever they may be, and creating a kind of a unified view of all those deployments for your business. Okay, so we're going to move on to, this is actually the MLOps deep dive, session 2. This is part 2, production model monitoring. So production model monitoring really has several different layers, right? There's, as we discussed before in the first session, there's service monitoring, where you need to look at how your processes running, there's drift monitoring, and there's accuracy monitoring. Let's dig into each one of these and discuss them in a little more depth. So service monitoring is probably maybe the easiest to get your hands on, because this is how we monitor existing software products. So we should all have some kind of service monitoring or software monitoring tools within our organization. And what service monitoring is typically looking at is things that you would expect, like how many requests are we getting to this service? The responses that we're making back. If we didn't respond back, how many times did we fail to respond, right? The response time, so how long did it take us, or the latency, you could think of it that way. There's a latency of the service, like we got a request and then we responded. So how long did that take? And then how many requests are we responding to, let's say per minute or per second, depending on what your service is trying to accomplish. And then you'd like to see that kind of over time. So you can see, well, okay, when am I getting the maximum number of requests to the service? This is all very standard kind of IT and software management type stuff, but it's absolutely critical, because if you don't set up your service to respond correctly, it doesn't really matter how accurate your model is. It doesn't matter, if it's working properly in other ways. If you can't respond to that request because you didn't allocate enough memory, or you didn't set up your service properly, that's not really going to matter. So service monitoring is really important. It's really the first layer that we need to look at and make sure that our services, our ML services, are up and running and responding to requests. Data drift monitoring can take on can use a couple different methods. I would say the most popular kind of base data drift metric is the Population Stability Index, or PSI, which is a metric which is used to calculate how different two data populations are. And this is really useful, because that's exactly what I'm doing in drift. I'm trying to figure out if my training data and my production scoring data are different from each other. And so when we run the Population Stability Index metric and we get a higher number, that tells us that the two populations of data for that given feature are different from each other, which makes the Population Stability Index really useful for drift alerts. And there are other ways you can measure and monitor drift, but PSI is a good place to start. And you can actually see some charts here from the data science data drift application that we have at H2O, which shows the drift of various metrics within a model. You can see in the upper right, and then you can actually drill in within this application, and you can see each of those metrics in more detail. So you can see, we can actually bin that feature and see where the drift is occurring within that feature, which is really, really important. Now, feature importance. It's important to understand drift in context. So when you're looking at a feature that has drifted, what a data scientist will do is say, well, is this feature important? And if it's an important feature in my model, then, and it is drifting above a certain amount, then that probably has consequences to the accuracy of my model, right? If it's a really unimportant feature with a very low contribution to the model's outcome, the fact that it's drifting may not be important. And this is a really important concept, because updating models in production, retraining them or refitting them, and running them through the lifecycle process, which we're going to discuss, has consequences. It's expensive. And so you want to make sure that you're monitoring your models and you're setting your drift alerts up in a way that you will retrain when you need to, not just because you there was some drift in some element. If that element is not changing your model in a significant way, you probably don't want to retrain yet. You want to wait, you want to watch, you want to see what's going on, and then maybe you want to retrain later if other things start to drift. Okay. And we can see this in some of the drill downs we just looked at in PSI, but there are other ways besides PSI where you can measure the differences between two data sets. And I have seen custom metrics built around this and other things to just measure the drift between the two histograms. And if you do that, you can have a different drift metric, right, that you can measure. And also, this is typically the kind of visualization that you want to see, which is a histogram, either two kind of line-based histograms or categorized histogram like this, where I can see what's drifting and get a better understanding of that, and decide that I want to throw an alert if any category is more than, let's say, 10% or 20% different between the two data sets. Accuracy monitoring, you notice I put accuracy monitoring third, and a lot of people would probably say, well, accuracy monitoring should be first. If my model's not accurate in production, then I should replace it. And so accuracy monitoring, let's kind of make sure we all are grounded in what that means. It means we're comparing the actual values of things that happened with the predicted values that we had from our model. And the reason why people might think of that first is that that's exactly how we figure out if a model is good when we're training a model. We use a holdout, a test set, and we actually, where we know the values, right? Whether we were, whether the person churned or not, or whatever the model is, and we use that holdout, we use that test set to compare with our predicted results for that same data set. And then we know if our model is accurate or not. So that mindset kind of pervades into the production environment as well. And people say, well, I've got to have the actuals, otherwise I can't know if my production model is good. Okay. Now, the problem is that accuracy data is one of the most difficult types of data to get your hands on and to utilize for a couple of reasons. And this is kind of mind-bending in some ways. First of all, actual data, like a prediction that I make and seeing if that prediction comes true, can take quite a long time in some cases. Now, in some cases it's short. I want to predict that you will click on this item on my website, and you have a session, and that session lasts 1 minute, and then you're done. Well, I'm going to know if you clicked or didn't click. Okay. Or I'm going to make a prediction whether you will repay a loan or not. Well, if that loan has a term of, let's say, 5 years, I won't know if you repaid the loan for 5 years. I might know if you default before 5 years, but certainly probably years in the making. So there's certainly a challenge of just the duration of time that things take when you're looking at getting prediction actuals back into the system, right? The other thing is that these systems can be remote. So we're looking at an IT project. So here I am, I've got the production model up and running in Kubernetes. I've set up my service. It's taking requests, it's responding. Now, where are those requests going? Well, they're getting integrated out into a set of applications that I'm running my business. Those could be customer-facing applications. Those could be business applications, my CRM system, all kinds of systems out there that I'm integrating these results into. Now, the challenge is I have to then go out to those systems. It's a different project, a new project, to go bring those actuals back in. Okay, so you'll find that getting actual data back may be a lot more challenging than you thought. This is kind of really the mind-bending part, is that when we make predictions, we kind of change the future. So sometimes a prediction that we're making is not about, predicting that, the person will click or not, right? Sometimes the prediction causes us to change our behavior. So if I'm deciding whether to give you a loan or not, or to give you credit or not, and my model comes back and says, don't give them credit, well, then I'm going to deny your credit request. That relationship kind of stops there. I have no idea if you wouldn't have paid your credit card or you wouldn't have paid on this loan because I didn't give you the loan as a result of the predictive model. So in that case, I can say I didn't give them credit, but I can't say whether they would have paid or not. So you can see that actuals and accuracy monitoring is a bit more nuanced than maybe we all thought. And so as we deep dive into the topic, hopefully you have a better understanding of why it's difficult. And as your organization is thinking about it, now you'll have a better way to talk about it and understand some of the barriers. Alerts are a critical part of monitoring. So it doesn't really matter if you're monitoring all these things, if no one knows that it's happening, then and can't take action on it, then the monitoring isn't really doing its job. So alerts is a critical part of this. You need to be able to set up alerts on the various metrics that we talked about, and those need to be customizable. So each model has a different level of criticality within your business. One model could be attached to a mission critical application. And if that application is not functioning properly, it has huge implications to your business. It could be worth millions of dollars a day, right? So monitoring that, even for the slightest changes, could be really important. And you may want to mobilize the team that works on that model, whether it's the ops people and even a data scientist, if something goes wrong with that model. You may want to do that through an incident response system, right? You may want to connect your MLOps system to something like PagerDuty, so that if that model has a problem, all of a sudden PagerDuty alerts are going off and the IT team is on that in minutes. That being said, some other models may be less critical to the business, or some people on that notification chain may not need to wake up in the middle of the night. So you need other ways to notify people. And so you might also need things like Slack alerts or email alerts, or even sending text messages around this. So you need a variety of alert styles, and you need to be able to kind of configure those depending on the severity. And users should be able to kind of subscribe to those depending on their role. So as an executive, I may want to know which models are having issues. So I may either log into the system to see that. I may push that information off into my own dashboarding system, or I may just subscribe to a general Slack channel on model alerts. So alerts are really important. From a deep dive perspective, just understanding that not all alerts are created equal and not everybody on the team wants the same alerts is a really important concept to understand. Canary models and tests. So one of the other ways you can monitor a model in production is by putting a secondary model in production, which has predictable behavior. So some models are more accurate, but maybe less well understood, shall we say. And some models are maybe a little less accurate, but more well understood. Like, let's say I use a linear model, a GLM, right? And that model is well understood. It's very explainable. I trust it. I know what it's going to do for every situation that's out there. And I've got my new model, let's say that I've introduced, and I know that my new model is, typically responds a little differently than my GLM. what I can do is set up some metrics around that to kind of monitor the differences between the two. And when I kind of warm up my system, I can figure out these differences and say, okay, you know what, I'm going to set up my canary. And while I don't really understand what's going on behind the scenes here, and I don't need to, if my production model starts to behave very differently from my canary model, then I can assume that something might be going wrong with my production model. And I can then look at my production model and try and figure out what's going on. So canary models, I just wanted to introduce that concept that you can have not just metrics that you're measuring against, but you can actually have other models that you're measuring against to see if your production model is working properly. Okay, now we're going to move on to part 3 of this MLOps deep dive. This is actually session 2, production lifecycle management. So we talked about this whole process of production operations before, which is really about testing models, understanding if they're working properly. If they're not working properly, we want to kind of troubleshoot them. We want to have methods to manage them, and we want to get a new model up and running in production as quickly as we can. In the meantime, we don't want our services to go down. We want to make sure that they continue to respond. So let's drill into some of these key areas. So one of probably the least well understood, but really most important actions we can take in production lifecycle management is just making sure that our models, as they enter the production environment, go through some production testing. And I have heard this called warm up and dev test prod and all kinds of things like that. The point is that when I bring that model in, I'm actually going to need to set it up and run it on a production-like environment that's very similar to what I'm going to run in production. So if I'm using Kubernetes, I probably want to deploy this model out to a Kubernetes cluster. I want to start running it with some traffic through it. It doesn't have to be live traffic. It could just be a data set. It could be data sets replicated over and over again, but I want to run it through its paces because I want to see how it performs on that production infrastructure and in that production environment. And in doing so, hopefully I will identify any problems that I might have introduced with that. So let's say there were problems with my code that I introduced as part of my runner, my dependency code, and the model doesn't perform well in certain areas. Hopefully I can deduce some of that by warming it up and testing it, right? Or let's say this model doesn't run well on the production configuration that I put it into. I should find that out through warm-up testing, ideally. So you're going to run it. You want to see what its footprint looks like. How much memory does it use? How does it respond? Things like that. This gives you confidence that when I roll this model into my prod environment, I understand its performance characteristics. And that's kind of the most important thing here is, do I believe that this model kind of set up on my production infrastructure is going to operate as I expect in terms of service levels, response time, throughput, things like that? How long you have to run this process for is very dependent on how critical this model is and what kind of business you're in. I talked to a bank some years ago, and their answer to that question was, well, a model may have to run for months in this mode before we can even look at it, because they want to make sure that the model could see a production load for a long period of time. They may even use the production traffic, by the way, route it to the model, but it doesn't provide production responses. So you could do it with kind of mock-up data, and a lot of times what you'll see is the actual production data will hit this model, but it won't provide any responses. You'll just put those responses off into a database, and then you'll compare those responses to those of the production model as well. right? And if you have accuracy data and other things, you can use that to measure the two and compare them. But it's much more of an analytic process at this point than a real-time process. It's much more of a batch process, I guess, than a real-time process, right? Nevertheless, having models in a production environment, warming them up, see how they perform is a really important characteristic of model lifecycle management. A/B testing is another one. So imagine I have a model that I've warmed up. I like it. It's working really well now, and I've run production data through it. But now I actually want to see if it is better than my production model on that live traffic data. And there are a number of situations where this is relevant, and there are some where it isn't, right? Where you may say, hey, the other model is working better, or I know it's more accurate from my testing, and I just want to go ahead and replace my production model. Fair enough. And sometimes you want to run an A/B test. The A/B test, I think, is particularly relevant when you're bringing a net new model or a challenger into production environment, and you may want to run a small amount of traffic through the challenger and compare it to your champion, and see just to confirm that your challenger actually does provide better responses than your current model. Now, that being said, all of the challenges with accuracy monitoring that we discussed before come into play here. You have to be able to measure the response to the model in order to do this type of testing. If not, how will you compare the two models, right? So you want to think about that a little bit as you're thinking about whether or not you can do A/B testing in your production environment. Sometimes it's just not really possible to do. I think one of the aspects of model lifecycle management that people don't think about but should is troubleshooting and the next step, which is kind of failover. So one of the aspects that you should be looking for in MLOps is, do I have the information that I'm going to need to troubleshoot production issues? And that's going to come in the form of, do I have kind of a full event log? Do I know everything that happened in the system over time? Do I know, all the events correlated with all of my alerts? Do I have a full set of, audit trail or access logs? And are those correlated with those other events? Because you can imagine, as you're trying to figure out what happened with a model that seemingly was running well in production up until that point, you may want to go back and look at, well, what happened in the system prior to that? There might have been events which took place, updates that took place. Someone came in, updated a model, deployed it into production, and then 24 hours later, that model is not performing well. Okay, well, that gives you some insight, and it maybe gives you some insight into what you could do about it, right? Because maybe it was that new version of the model that wasn't performing well. On the flip side, what if a model has been running in production for a long time? You go and look at all of this information, and all of a sudden, data is drifting or something like that. That's part of this troubleshooting process. You go, oh, it's data drift that we're going to want to go fix. So then what do you do? Well, I have heard even experienced people from data science team say, oh, we'll just stop things, we'll fix it, and we'll update the model in production. And the challenge with that thought process is that's not a production mindset. The production mindset says, no, we always have to provide a timely response. So even if the model is not performing well, we need to have alternatives. And that alternative could be another model, as we talked about with the canary model. It could be another model that I can flip over to while I'm fixing my main model. And maybe that model isn't quite as good, but it does provide a reasonable response. So I could flip over to that. I could flip over to a rule or a set of rules. I've definitely seen that work. In one example I know of, there was a memory allocation model. So we try to optimize the amount of memory allocated to a server for a given deployment. And before the model, you would just allocate the maximum amount of memory to every server, and that was a waste because not every use case needs all that memory, right? So in order to optimize that, use a model to predict how much memory that server will need. Now, if that model stops performing properly, like what's your fallback option? Well, for the time being, for a day or two, while you're fixing the model, just give everybody the maximum amount of RAM. It's going to cost you a little bit more for that time period, but you know they're going to be successful because they've got enough RAM to do anything at that point. So you can see what I'm saying. Sometimes it's a model. Sometimes it could just be a simple rule that says, oh, fail over to 64 gig of RAM, and then we'll come back a couple days later. We'll fix the optimization model. We'll rerun these. This batch of transactions, and we'll figure out and reset those specific deployments to the correct amount of RAM, right? So you can see how you can have a process where my model is failing. What am I switching to? I switch over. Now I've got a process got time. That's the other thing is you're going to need time. This isn't going to happen in a window where no one else is going to notice, right? So I've got time to fix it. I've got a failover option that I know works. And then when I'm going to bring my model back up online, I can then fix kind of perhaps whatever challenges I may have introduced for myself. And if you go to another model, like let's say I just go to a linear model and that seems to perform pretty well, I just roll with that, right? And then maybe update my model a couple days later and start using the slightly more accurate model in production. Also a perfectly reasonable fix. All right, we're in the MLOps deep dive. It's actually session 2. We're going to talk about production model governance, part 4 of this presentation. So production model governance is oftentimes the most overlooked area of operations, but shouldn't be. We should be thinking about this, especially as folks who are concerned about production operations. This is an area we should be it should be top of mind for us, and we should be thinking about how we're going to solve some of these problems up front before we start getting models deployed into production. And it includes a number of areas, including things like access control and audit trails, versioning, history, what we could call lineage. We'll talk about that, and any other controls and reports that we feel like we're going to need for production management. So access control is particularly important here. A lot of times when we have a data science project which gets pushed over and used in production, we don't have the proper controls on the models that we have on other software that we have in production. And that could lead to issues. What if someone decided they wanted to manipulate that model, right? If we give people access who we wouldn't normally give access to production systems, if we give them access to the models themselves or to the production systems where they're deployed, that could cause issues. And there could be people who are doing that for kind of nefarious reasons because they want to manipulate the model. It could just be someone who doesn't really understand the nature of production introduces some bad code, which causes the whole system to fail. So access control is about security. It's about reliability and stability as well. We want to make sure that the people who have access to production models, who can promote a production model, a model from, let's say, testing to production, right, is a limited set of people who are trained on that process, who understand production issues, right, and what to look for. What are the checks and processes they need to go through before putting that model into production? They understand the testing procedures that it needs to go through. So you don't end up with someone taking a model which wasn't tested and putting into production where it will break, right? Integrating with existing access management tools is a great idea. That's like your Active Directory, your LDAP system, your role-based access control mechanism, whatever those are. It's a great idea if MLOps integrates into those, because roles change. People leave the group, people leave the company. And what you don't want is someone has access to production systems who isn't working on that project anymore. So as you think about production model governance, you want to think about having pretty tight control over who's involved in the production process. Make sure that you know who those people are, that they're properly trained, and that you have process, procedures, indeed controls in place for how to promote models into production. So when we think about governance, we think about governance controls. This is clearly part of that. Now, part of having that process in place is being able to ensure that that process is happening. And so audit trails are a really, really important part of governance and compliance, because if we say in our governance controls that we are going to limit access to these systems to only people who have been trained, we need to track that. So we need to know who had access, and we need to maintain an audit log of everyone who had access. We need to maintain a log of every process that was updated. So you should maintain a access log, you should maintain an event log. You really have to look here at, depending on your industry, what logs and information am I going to need for compliance? But I would also say, ensure that you have whatever information you would reasonably need for any legal issues you might face. So just as an example, let's say that you're being sued, you're a credit card company, and you're being sued by someone because they're saying that you were biased in your credit scoring application, and that you didn't give them credit because of their, let's say, their race or their gender, which of course is, some of those things were made famous in the Apple Card scandal around Steve Wozniak and his wife. So let's suppose that something like that happens, and then we need to go back and figure out, well, okay, what was going on in the system at the time. So that's not troubleshooting, that's more of a compliance issue or a legal issue. So we need to make sure we have all of the kind of audit trails and logs that we'll need in order to gather that information, to understand what was going on. And that's where we're going to see a lot more around some of these other capabilities as well. So versioning and rollback of models is really, really important in MLOps for a variety of reasons. First, when we put things into production, we need to maintain a full history of what was going on in production. So if I put a model into production and then I replace it with a new model, what we don't want to have happen is the old model artifact that we were using before just gets thrown out. We actually want to maintain a repository of the models, and we want to be able to go back and find that model. It could be a year later, we need to go back and find that model, and we need to reproduce that model's prediction a year later, right? So you want to think about, okay, I not only need kind of audit logs and capabilities, but I need to actually store the artifacts that I would need to reproduce this at some time in the future. And your version history should probably look something like this. And I put a number of events here on the timeline. You can see that the model was introduced originally, that was version 1.0. And then I went through a series of updates to that model. Maybe I just refit the model a number of times, 1.1, 1.2, 1.3, 1.4. And then I introduced a new, an updated version of that model. Maybe I retrained, I retuned it, I changed the tuning parameters, or even introduced a brand new algorithm that's 2.0. Then I updated that model a few times. And then you can see, and this is one of those interesting insights from working in the field for a while, the current production version is 2.3, and I put the pointer on that one. That's the model which is serving the majority of our requests right now. And then I tried to update that model to 2.4. That model update failed. I don't get rid of 2.4, right? That is useful information. I tried to update the model. I tried to put this into production, or I brought this model in and I was going to update it and it didn't succeed. So I introduced 2.5, or maybe I fixed 2.4 and I introduced 2.5, which I'm now running in an A/B test with my current production model. Okay, so not only that, I have 3.0, a new model, maybe retuned, maybe a brand new algorithm or something that I am warming up right now. On, let's say I'm routing those production requests over to 3.0. I'm seeing how it responds, and I'm comparing that on an offline test to my current model, right? So you can see all the kinds of different tests and things I could be running simultaneously within this production environment. And I need to track and manage all of that and understand what's going on. The other thing that could happen is I could be running, let's say 2.3, something goes wrong, and I want to roll back to a prior model, like 2.2. I should have that model ready to go and ready to redeploy and update the production model with my 2.2 version. And as I pointed out here, it may not be trouble. It may not be a performance problem. It may be that I realize that the 2.3 version we introduced some bias or let's say in the 2.0 version, we introduced some bias that we didn't know about. I actually need to roll back to 1.4 because that's the last version of the model where I believe that the bias wasn't included. Okay, that's why I need a version system and version history like that. Okay, another thing in governance that's really important is just understanding the overall lineage of the model. So many people are probably aware of the concept of data lineage, which is where did my data come from? In this case, we're talking about model lineage. So models can come from a variety of systems. It's not always the case that you have a single system of record for producing models and a single system of record for deploying those models. That's the case in some very isolated systems, but in MLOps, you can have models that, I could have models coming from this data science team, that data science team, some models written in R, some models written in Python, some models written by Jason, some models written by Dan, by Ben, So all of that information I kind of need to collect and gather at the production side so that I know a year later that this model was kind of published by Ben, it came from the risk team on this date, etc. All that information needs to be captured over on the production system, right? Is this model a net new model, or is an update of an existing model? We saw that in the versioning, but we also need to capture that in terms of the model's information, the metadata around that model. We talked about the built it and group. Did we test it, right? What data did we use to test it? All that information needs to be tracked, right? Ensure that we did that testing and then deploying that model to production. So all of these steps need to be tracked, and I need to capture kind of who, what, when, where, why around all of these steps so that I can go back in time and look at that. So governance overall is about a lot of those things. It's about having the right controls in place to ensure that that the right people are updating models and that you're not making mistakes through lack of training or through nefarious intent of some kind that people might have around your models. And then it's a lot about tracking what's going on so that you have all the data you need to not only troubleshoot, but also to provide for legal and regulatory compliance around your models. What you don't want to have happen is you have a legal issue 6 months or a year from now, and they come to you on the operations team or the data science team and say, well, what happened? And you say, we don't know. We don't have any of the data. Like, we don't even know what model was running back then. Or I think maybe, John over in the other room might know what model was running. you can't count on that level of information. You can't have tribal knowledge. It should all be in the system, stored and managed, so that you can go reproduce what was going on a year ago, understand exactly what was happening, and comply with whatever requests you might receive. Okay, with that, we're going to look through some of the questions that we've had during the session, and then we will go ahead and wrap things up. Let me get to some questions here. Okay, here's a good question about scoring pipelines, and I'm sure this goes to how I was talking about pipelines at the very beginning. So a scoring pipeline, I thought a pipeline was a flow from data to model. Well, a pipeline in the production side can mean a pipeline is any flow, right? And you can have a production pipeline. A production pipeline means it receives requests and it responds to those requests. And the information in that pipeline goes through the same series of transformations that you saw in training. So I have to do any data preparation transformations, maybe to that piece of data. I need to transform it. I need to do feature engineering on that piece of data. So it goes through the feature engineering steps. And then I need to submit it to the model where it will be scored. And then I need to respond. So that's a production pipeline. Production pipeline is processing through all those same steps that you did when you built the model, but on the scoring side. So the next question is, are the alerts based on the threshold? Typically, yes, alerts are based on a threshold that you set. And so the system should allow you to, depending on the type of alert you're setting, if it's a metric like PSI, you would set a threshold and say, if PSI for any metric goes above 0.1, then alert me. And typically that system will be monitoring that periodically. So you could say, and I want you to go look, I want you to run that alert every hour. If it's a more critical thing, you might say, I want you to run that every couple minutes, right? And tell me if you see anything. So yeah, it's based on a threshold. So here's an interesting question. You know, could the alerts be modeled and monitored by AI itself? I'm sure it could. I think maybe it will in the future be an AI function itself, where AI is monitoring the production AI. Right now, what I've seen is that people want a lot of control over the alerts themselves. And so they want to be able to tell the system, hey, notify me when this event happens. So just like a lot of other things in business, this is going to be a rules first kind of function. And then maybe once we become more comfortable with those rules, we could put models in place to let us know that, oh, this is a significant deviation and therefore we should alert on that. But for now, I think it's going to be, you'll see mostly rules. Okay. So does H2O have ways to integrate with things like Splunk? Yes, we do integrate with Splunk with log management. You absolutely do want to integrate with your kind of logging tools. What I have seen in MLOps in the past couple of years is that some of the best practices is that you want to be able to access those logs as you're troubleshooting. So you definitely do want to be able to integrate with the underlying kind of log management system. And ideally, you'd like to directly access the logs at the time when your event was happening. So yeah, you want to integrate with something like Splunk. You want to be able to access the logs there so you can see what was going on. What Splunk's going to be tracking, by the way, is a lot of the underlying infrastructure logs. And you're going to want to see those because, as we said, system goes down, now I'm troubleshooting. It may have nothing to do with your model. It may not have anything to do with your modeling environment. It may have everything to do with some downstream process or underlying infrastructure, which was having trouble, which is, let's say, getting overloaded. And you just need to know that. Like, oh, we were overloaded, our system was overloaded that was trying to support the transactions. We need to fix that before we can support the service again. Here's a question about rollback. You know, how realistic is it to roll back with changing inputs and outputs? It is true that if the data is changing over time, and the reason why you updated your model in production was because the profile of the data set had changed, then you can't really roll back to a prior version of that model, or that model, it won't understand what those data inputs are, right? So you'll definitely want to be cognizant of that. So if the new model you've introduced is because of new data elements, your old model, you can't really roll back to your old model. Now, I will say I'm not a big proponent of needing rollback in the first place. I think you can minimize the amount of rollbacks you could go through if you do robust testing on the front end. So if you test your models, if you warm them up, if you run the right tests to make sure that your model code is consistent and works properly, you shouldn't need to roll back, right? You're going to test your model, you're going to run it, make sure it works. And you're right. If you're going to roll back, you need to roll back to a model which will actually understand the request that it's getting and provide a correct response. Okay, just trying to get through a variety of questions from a variety of folks here. We're almost at the top of the hour. Let me see if I can do one more question. Good question here about, can you point me to Mojo in AWS? Terrence, happy to do that. If you want to just reach out to me, happy to. I'm dan.darnell@h2o.ai. And if you want to reach out to me directly, I'm happy to get you some more information on AWS Lambda and point you to the right folks. Yeah, I think we'll just wrap it up there. And I want to thank everybody for joining us today for this deep dive session on MLOps.